Welcome back, guys. So this is question 2.23 of the book Electric Circuits by Nilsson and Riedel, and the statement of this question is the variable resistor R in this circuit in figure P2.23, this is the figure P2.23, is adjusted until I naught equals 10 amperes. This is I naught which is flowing through this 5 kilo ohm resistor. Find the value of R for which this current, when it is adjusted, this current is 10 milliamps. Okay, so we have to find this resistance. This is the variable resistor, and with the help of the knob or anything else, this is adjusted in such a way that the current which is flowing through this 5 kilo ohm is what? This is 10 milliamps. Okay, so the only quantity which we have now is this I naught, and the value of I naught is 10 milliamps. Okay, so if this is 10 milliamps, let us have here this voltage, let me call it V naught. So the current through this resistor is known, that is 10 milliamps, and the value of the resistance is also known. So we can very easily find out the value of V naught, that is I naught multiplied by 5 kilo ohm. So 5 kilo ohm is 5 into 10 to the power 3. So let me put these values. I naught is 10 milliamps, so 10 to 10 to the power minus 3 multiplied by 5 into 10 to the power 3. These two will cancel out, and here V naught is 50 volts. Okay, so the value of V naught is known, and that is 15 volts. Let me, okay, so this is the V naught. Apart from it, another quantities which are known are here. We have, let me call it VA. At each of the node, let me identify the voltages, and let me call it VB. Okay, this is, let me call it the ground one, and the voltage here is 0. Okay, so the value of VA, which is from this source, and we can see that this is VA minus 0 minus 80. So the value of VA is 80 volts. So the value of VA is also known, and that is 80 volts. Okay, so if this value is 80 volts, this value is known. So if we have this scenario that we have here Vx, here we have Vy, and certain voltage R, we can find out the current through it by the formula, which is I is equal to the potential difference divided by the resistor. So the potential difference here is Vx minus Vy divided by R. Okay, so let me apply the similar formula here, and in applying it, let me have this current here, let me call it I 1.5. okay, so the value of I 1.5 is the potential difference, which is VA minus V naught divided by 1.5 kilo. So let me put these values here. So the value of VA is 80, the value of V naught is 50, and the value of the resistance in between them is 1.5 kilo. Okay, so it would be 30 divided by 1.5 kilo. So we can find it out, and it will be 20 milliamps. Okay, the value of this current is also known, and that is 20 milliamps. Okay, so this is known. Now at this junction, we can see that this current, which is 1.5, is coming towards it, and it is now splitting into two parts, which one is I naught, the other one is going through this 3 kilo ohm resistor. Let me call it I3. Okay, so by applying KCL here, okay, if I will apply KCL here, I can very easily see that, let me use this black color for it. Here I can very easily see that I 1.5 is equal to I naught plus I3. Okay, the only unknown current here is I3. So I3 can be found out by I 1.5 minus I naught. Okay, let me put these values. So I 1.5 is known, that is 20 milliamps, and I3 is, I naught is also known, that is 10 milliamps. So 10 milliamps. Okay, so the value of I3 is now 10 milliamps. This current is also known. Let me underline it as well. So these currents are known. Let me remove this one. So these things are now known. Now this current is here, we can very easily find out the voltage across it. So V3K, let me have this voltage here across this one, and it would be what? It would be I3 multiplied by 3K. So I3 is known, that is 10 milliamps. So 10 into 10 to the power minus 3 into 3 into 10 to the power 3. These two will cancel out and we will get here 30 volts, which is across this one. Okay, so this is again the voltage which is known. So from it, now we know this voltage, we know the consumed voltage as well. We can very easily find out this voltage now. So from the formulation and from the potential difference formulation, we know that V0 minus VB, which is the potential applied and the potential which is remaining, that is equal to the consumed power, which is across this 3K. Okay, so from it, we only don't know this VB. So VB is equal to what? That is V0 minus V3K. The value of V0 is known, that is 50. The value of V3K is also known, that is 30. So this is here. So from it, the value of VB is 20 volts, which is here. Okay, so this is the 20 volts, and again this one is known. Now when this voltage is known, the potential difference is known, the resistance is known, we can very easily find out this current. Let me call it I5. Okay, by applying the formula, which is the potential difference across this resistor divided by the resistance. So applying it with here, we will get I5 is equal to the VB divided by 500. Okay, the value of VB is also known, that is 20. So 20 divided by 500, and applying it, it will be 1 over 25. So ultimately this is 40 milliamps. Okay, so the value of I5 is also known, and that is 40 milliamps. Okay, so when this one is known, what is the objective of finding it here? We need to find out the potential difference here, which is VR. We need to find out the current here, that is IR. If these two quantities are known, we can very easily find out the third quantity. So let me call here this IR. If IR is coming towards this node and this I3 is coming towards this node, these are combined together and give me this I5. So again applying at this node the KCL, what will I get here? Let me use this color. So applying KCL here, it will be I5 is equal to I3 plus IR. Okay, I5 is known. Yes, I5 is known, and that is 40 milliamps. Okay, the value of I3 is known. Yes, that is 10 milliamps. So the value of IR is I5 minus I3. Let me put these values. So I5 is 40 milliamps. Okay, and the value of I3 is 10 milliamps. Okay, so we will get 30 milliamps here, and that is the value of the current which is flowing through this resistor. This IR is known. Now in order to find the value of VR, we have two voltages across it. One is this VA, the other one is this VB, and from the potential difference formula, we know that, let me use this color, we know that VR, which is the potential difference across this resistor, or that is the voltage which is consumed across this resistor, that is equal to the applied voltage minus VB, which is the remaining voltage. So VA is 80 volts, which we have found in the very start, and the value of VB, let me see that where is VB. So it is VB, so that is 20 volts. So we will get here, this is the value of the voltage across this resistor is what? That is 60 volts. Okay, so now we have this VR, we have this IR, both of them are known. I have told you that with each passive component we have three quantities relevant with each other. One is the current, the other one is voltage, and the third one is the resistance. If two of them are known, we can very easily find out the third one. So let me solve it here. Okay, let me solve it here, and by applying the Ohm's law, we can see that R is equal to VR divided by IR. Okay, the value of VR is known, that is 60. The value of IR is 30 into 10 to the power minus 3. So solving it and finding all the values, we will get it 2 kilo ohm, and that is what? That is basically the solution for our question. So what we have done, so initially in order to find out the value of this R for the current which is here, and the value of current was known, that current should be 10 milliamps, we had to find out the value of the potential difference and the value of the current which is flowing through this resistor. So for finding it out, we have found out all the voltages, all the node voltages, all the branch currents in this circuit, and ultimately we have found out the value of this resistor should be at 2 kilo ohm, so that it can provide me the value of I naught equal to 10 milliamps. So that is the solution of our question 2.23. If you have any question regarding the solution of our question, you can ask me in the comment box. See you soon.